everyone, my name is Christina. And I've always been fascinated by the ocean, its movement, its sound, and its endless power. Today, I want to share the story of how I discovered energy hidden inside the waves, and how people around the world are learning to turn the ocean's motion into clean electricity. I grew up near the coast, where the sea was part of my daily life. Every morning, I would wake up to the sound of waves hitting the shore, soft on some days, powerful on others. When I was little, I simply thought the waves were beautiful. I never imagined they could become a source of clean, renewable energy. But everything changed the day I joined a marine science club at school. On the first day of the club, our teacher, Dr. Sanders, showed us a video of giant machines floating on the ocean, moving up and down with the waves. He said, "These machines can turn the sea's motion into electricity." I was amazed. I had seen wind turbines and solar panels before, but this was different. This was the ocean, wild, unpredictable, and alive, working together with technology. I decided right then that my project for the year would be wave energy, also known as ocean wave power. I wanted to understand how it worked, and why scientists believed it could change the future of clean energy. My journey began with learning the basics. Waves are created by wind blowing across the surface of the water. When the wind transfers energy to the ocean, the water begins to move in rolling patterns. These waves carry an enormous amount of energy, much more than most people realize. Unlike sunlight, which changes with time of day, or wind, which can suddenly stop, waves continue moving even long after the wind has faded. That steady motion makes them an incredible resource. I learned that wave energy is usually captured by special devices placed on the surface of the water or anchored to the sea floor. One of the most common devices is called a point absorber. It's a floating machine that moves up and down with the waves. Inside it, a system of mechanical parts, often a piston or hydraulic pump, pushes and pulls as the waves lift and lower the device. That mechanical movement is then converted into electricity using a generator. Another device is the oscillating water column. This one looks like a hollow chamber built partly above and partly below the waterline. As waves enter the chamber, the water inside rises and falls, pushing air through a turbine. The turbine spins, and the generator produces electricity. I found it amazing that something as simple as moving air could power entire buildings, when designed correctly. But my favorite type of wave energy device was the hinged buoy, or sea snake. It is made of several connected sections floating on the water. As waves pass beneath it, the sections bend at their joints. That bending motion drives hydraulic pumps, which generate electricity. Watching videos of these machines looked almost like watching a giant sea creature swimming peacefully on the water's surface. After learning the theory, I wanted to see wave energy in real life. Fortunately, my school arranged a trip to a coastal research station that focused on renewable marine technologies. The station sat at the edge of a rocky shoreline, and from the pier, we could see various prototypes bobbing in the waves. A researcher named Maya welcomed us and guided us around the station. She explained that wave energy devices must be incredibly strong because the ocean can be unpredictable. A peaceful day can turn into a storm quickly, she said. So every machine must survive powerful forces, saltwater corrosion, and constant movement. Maya also told us that engineers are testing different shapes and materials to make these devices both efficient and durable. Some are made of steel, others of reinforced fiberglass or special composites designed to resist rust and wear. I loved hearing about the creativity behind each design. Then came the moment I had been waiting for, seeing their wave energy device in action. We walked along a long pier to a floating platform. Attached to it was a bright yellow point absorber. It rose and fell with the waves, almost like it was breathing. As the device moved, Maya pointed to the cables running from the platform to an onshore station. "The movement you're watching right now," she said, "is already being converted into electricity. It's not a huge amount yet, because this is a prototype, but one day these machines could power entire neighborhoods." I leaned on the railing and watched the waves lift the device again and again. It was simple, repetitive, calming, and yet, each movement was producing clean energy. I suddenly realized how clever nature is. The ocean never stops. Even the smallest waves carry energy, and the biggest ones carry enough power to transform entire cities. After returning home, I spent weeks reading more about wave technology. I discovered that countries like Portugal, Scotland, Australia, and Japan are leading the way in ocean energy research. I learned about offshore farms where dozens of wave devices are connected together, forming a network that can supply electricity to local communities. Of course, wave energy also has challenges. These machines are expensive to build and maintain. They need to survive harsh storms and avoid harming marine life. But every year, engineers are improving the designs, making them stronger, safer, and more efficient. Many scientists believe that wave energy could one day become one of the largest sources of clean electricity in the world. Inspired by everything I learned, I decided to create my own small wave energy model for the school science fair. I built a miniature oscillating water column using a plastic bottle, cardboard, and a tiny turbine. When I placed it in a tub of water and created waves by hand, the turbine began spinning. It was small, but it worked, and it made me feel like I had brought a little piece of the ocean into the classroom. As I watched the turbine spin, I thought about something Maya had told us at the research station. The ocean has been moving since long before humans existed. We are only now learning how to listen to it. That sentence stayed with me. It made me feel connected not just to science, but to nature itself. Today, when I stand on the shore and watch the waves roll in, I no longer see them as just water. I see them as endless possibilities, a clean future, a smarter planet, and a reminder that sometimes the answers we need are right in front of us, moving gently with the tide. And that is my story of discovering the incredible power of wave energy. I hope it inspires you to look at the ocean with new eyes, just like it inspired me.